So here are some examples of work which span 0 to positive to negative work. So in the first example, let's say you had a mass m on a frictionless level surface, and there was the force of my hand on m, and in the same direction as the force and parallel to it, the mass displaced a distance delta x. So let's just say that the mass was 1 kilogram. The force of my hand on the mass m is 2 newtons, and the displacement to the right is 3 meters. And as you can see from this picture here, theta is equal to 0. Delta x and f of h on m are parallel to each other. So in that case, the work done by the hand on the mass, note the turn of phrase here, is equal to the magnitude of the force, that would be 2 newtons in our example, the magnitude of the displacement, that's 3 meters, and the cosine of the angle between those two vectors, cosine of 0 is 1, and so that's simply 6 joules. Second example, exactly the same scenario as one, except now the force of the hand on the mass is elevated, let us say, an angle theta, where theta is equal to 20 degrees. And so in that case, the work done by the hand on m is the magnitude of the force, 2 newtons, the magnitude of the displacement, 3 meters, times the cosine of the angle between the two vectors, 20 degrees, and that's 5.64 joules. So you should stop the video and just confirm that you get what I get. Third example, let's say now that you are holding the mass up in the air, and you're exerting a force upward equal and opposite to the mg of the mass. So in other words, you're supporting it, but at the same time you are moving it in the horizontal direction. So in that case, the work done by the hand on the mass is 10 newtons. I'm using easy numbers here. The magnitude of f of h on m has to be equal to the magnitude of mg. If m is 1 kilogram, using easy numbers, 1 times 10 is 10 newtons. That's where that came from. The displacement is 3 meters. The angle between f of h on m and the displacement is now 90 degrees. Cosine of 90 is 0. No work is being done by the hand on the mass, by the definition of work. Okay, fourth example. Let's assume that the mass is sliding, displacing itself to the right. And we want to consider displacement delta x, and we want to discover what the work done by the hand on the mass is when this force of h on m is directed anti-parallel to the displacement. So the work done by the hand on mass is equal to 2 newtons, so we're going to take this to be 2 newtons as we did in the first example. The magnitude of the displacement is 3 meters, same numbers we've been assuming. But now theta is equal to 180 degrees, right? Let me write that in here. Theta is equal to 180 degrees. And therefore, the cosine of theta is equal to -1. And the work done is now -6 joules.